Hello, ladies and gentlemen, and welcome back. We're on the 2008 Fermat paper, and we're just about to start Part C. We'll be starting with question 21. Suppose n equals 1 plus 11 plus 101 plus 1001 plus 10,001 plus 100,001, all the way up to a 1 followed by 50 zeros followed by a 1. When n is calculated and written as a single integer, the sum of its digits is... Okay, so we have some options. So we need to figure out the sum of the digits. Now, what is n going to look like? And if we experiment just a little bit, now, 1, what does 1 plus 11 look like? Plus 101 plus 1001. Now, it can seem quite scary, but if we just take little cases, and this is something I do recommend you do when you're given something big that clearly has a pattern, take a look at some small cases, try and see what's influencing what. So if we just start with 1, what's just 1? Well, it's just 1. What's 1 plus 11? That's 12. So I'm just going to have sort of sum of the digits, so n, but obviously not the full n, and then the sum of the digits. Okay, and then if I add on 101, then I'll get 113. Sum of the digits is 5. If I add on 1001, I'll get 1114. And you might think, oh, it's just odd numbers. So here we have 1 0, 2 zeros, 3 zeros, so 1 0, 2 0, 3 zeros, all the way up to 50 zeros. Just extend the pattern and you'll be all set. But at some point we're going to keep adding ones to the units digits. You're going to get 9, and then it looks like it'll be 8 ones. And then I add on the next thing. I'll get 9 ones. But I'll want to add 1 to 9, and that'll carry over. Okay, so I think just straight recognizing a pattern like this and just obviously extending it, obviously, of course, in sarcasm quotes there, but just extending it blindly would probably lead you to one of these answers, like maybe 55 or something like that. But you have to remember, like, what's happening each time? Well, we're gaining a new 1 in a brand new decimal place, or a brand new place, a digit place. And then we're also always just increasing the units digit by 1. But eventually that starts to carry over. So I think it might be wiser for us to separate this and say, okay, this isn't just 1 plus 11 plus 101. This is 1 plus 10 plus 1. Plus 100 plus 1, and separate it out. Because eventually, so here would be 51 zeros. Because then when we collect it this way, we'll get, just taking, we'll use a little color here, taking the blue things that I'm underlining all together, each one will just put a 1, and we'll get 52 ones. Whatever that number is called. So just 52 ones in a row. So 52 ones. And then there are 1, 2, 3, so 51 of these, counting the number of zeros, plus 51 just plain old ones. And what is this ultimately going to do? Well, not a whole lot. So this is going to be 1, 1, 1, 52 ones in a row, plus 51 times 1, which is just 51. And when we add these together, it's really only going to affect the last 3 digits. So we'll get 1, 1, 1, 1, 1, 1. But then we add on 51, and suddenly this becomes 62 at the end. So the last 2 digits are affected, but we still have 50 ones here, and then a 6 and a 2. So 50 times 1 plus 1 6 plus 1 2, that'll be 50 plus 6 plus 2. And our answer will be 58. And I think that was A. Yes, A. And that's all we really need to do for that one. Okay, we found the right way to break it down so that we can easily calculate the sum of the digits at the end. And the key there was recognizing that most of these digits, the zeros don't do anything, but the ones, the leading ones, can all just sort of be separated and held off to the side. And then there's also just these other ones. Okay, there's 51 of those, and we're all set. So 58, and that does it. Up to we're now going to move on to question number 22. I will see you guys for that in the next video.